Here we are going to discuss number 8. It says a bakery produces two types of cakes, simple and extraordinary. So these are the two variables, simple and extraordinary. So you have a certain amount of simple cakes and a certain amount of extraordinary cakes. Okay, these are what varies. How many simple, how many extraordinary? Now, the respective processing times for each batch on the dough making machine. So we have to highlight this. The dough making machine, let's underscore that, are 20 minutes and 40 minutes, while the oven baking times, that's oven baking. So you have dough making and oven making, oven baking are 15 minutes and 54 minutes respectively. How many batches of each type of cake? Okay, how many simple and how many extraordinary? So these are the variables. These are what varies. Should be processed in an 8-hour shift so that both the dough making machine and the oven baking are fully occupied. So in the solution, it says you have to identify the variables, what varies, X and Y. So we can make X be simple. Let us make X be simple. Let X be simple and let Y be extraordinary. Okay, it doesn't really matter. Now, for the dough making machine, 20 minutes for X and 40 minutes for Y. For each X, you need 20 minutes. Okay, for each simple, you need 20 minutes. And for each Y, for each extraordinary, you need 40 minutes. And you've got a total of 480 minutes in all, because remember, it's an 8-hour shift. Okay, and the times for the machine is in minutes. So you have to calculate how many minutes are there in 8 hours. 60 minutes make an hour. So 60 by 8 will give us 480 minutes in all. That's all you've got. Now for the oven baking now, 15 minutes is required for the simple cakes and 54 minutes is required for each extraordinary. Again, we only have 480 minutes available. So the times for the simple, which is 15 times X, plus the times for the extraordinary, which is 54 times Y, must add up to 480 minutes. So you've got two linear equations and we have two variables. It is solvable. So we are going to apply matrices to solve this pair of linear simultaneous equations. So we have it properly set up, x on x, y's on y's, and the constants over the constants. So step one, we have to form a matrix equation. So it will be a 2 by 2 with the coefficients, a column that's 2 by 1 with the unknowns, x and y, and a column, another 2 by 1 with the constants. And here it is, 20, 40, 15, 54. These are the elements of the 2 by 2 times the column matrix x and y, x above y, because x comes first when you're reading from left to right, and 40 over 40. So here we have the matrix equation. Step 2 is to find the inverse of the 2 by 2. Now, to find the inverse of a 2 by 2 matrix, let's say A is equal to ABCD is 1 over the determinant times the adjoint. Okay, here's a symbol for inverse. It's a -1 on top right corner. So A inverse is equal to 1 over the determinant. The determinant you calculate it by multiplying the leading diagonal, that's A times D, minus the non-leading diagonal, which is B times C. Okay, so you start with A, multiply to D, diagonally, subtract, start with C or B, and multiply to C, subtract. And to find the adjoint now, what you do, you swap the elements of the leading. So A and D have to swap positions. Swap the positions of the leading elements. And the non-leading, you just change the sign. That's what it means by multiplying each one by -1. So you just reverse their signs. That's how you find the adjoint. Okay. Here they are saying that if the determinant is 0, then that matrix does not have an inverse. Here it repeats how to find the determinant over 2 by 2. The determinant over 2 by 2 matrix is formed by subtracting the product of the elements on the leading diagonal from the product of the elements on the non-leading diagonal. Okay, here it is. And the adjoint over 2 by 2, it says the adjoint over 2 by 2 is formed by swapping the two elements, swapping the position of the two elements in the main diagonal and changing the sign of the two elements on the off diagonal. Okay. So we need to find the inverse over 2 by 2, and that's how we do that. So here we have found the determinant of our 2 by 2, which is 20 times 54 minus 15 times 40, which is 480, coincidentally. And the adjoint is the swapping the positions of 20 and 54. 54 takes the position of 20, 20 takes the position of 54, and we change the signs of 15 and 40. They were both positive, they become both negative. So therefore, the inverse now of this 2 by 2 is 1 over the determinant, 1 over 480 times the adjoint. And here is our inverse for our example. Step 3 says now we've got to multiply the inverse of the 2 by 2 to the column matrix of the constants. So first check if the number of columns in the first matrix equals to the number of rows in the second. Okay. Then to find each element of the resulting matrix, multiply the elements of the corresponding row from the first by the corresponding elements of the column from the second and sum up the products. So that's how you multiply matrices, row times column. Okay, here is just to verify. At the beginning here, it is saying just to verify if multiplication is possible. Okay, so the number of columns of the first must equal to the number of rows of the second. So if that's the case, then you can multiply. And how is the row times the column? And you have to add the products to get one element. Okay, so 54 corresponds to 480 minus 40 corresponds to 480. So it's 54 times 480 plus minus 40 times 480 rows times column. Here it is, just to get one element in the product. Here it says again, multiply the rows of the first matrix by the columns of the second matrix. That's very important when you multiply matrices. You must do that. So again, here we go again, 54 times 480. You go across and you come down, minus 40 times 480. And then you do the same thing for the second row, minus 15 times 480 plus 20 times 480. Then you simplify each element. Okay, so 54 times 480 plus a minus 40 times 480 is 6,720. You can verify. And minus 15 times 480 plus 20 times 480 is equal to 2,400. You can simplify each of them. Okay, so the scalar multiplication now, remember we have a 1 over 480 outside to multiply by, and it is called a scalar, it's just a number. This is what I mean. The 1 over 480 is part of the inverse, you know. So we just use the matrix part to do the multiplication, and after now we're going to multiply by 1 over 480. 1 over 480 is called a scalar number. It scales up or it scales down the value. Here it's going to scale down because it's a fraction. Okay? So we just multiply each element by the 1 over 480 to wrap up the multiplication of the inverse to the constants. Here it is, the scalar multiplication. Multiply each of the matrix elements by a scalar. So 1 over 480 times 6,720 and 1 over 480 times 2,400, which simplifies to each element 14 and 15. And you can verify these calculations. So in step 4 now, it says to equate the column matrix with the unknowns to the column matrix of the product in step 3. So the unknowns are the variables, which are x and y. So we have to equate that column matrix to the product that we have found, 14 over 15. So x, y is equal to 14, 15. So step 5, you write down the solution. So x must be equal to 14 and y must be equal to 5. So in order for the dough making machine and the oven to be fully occupied, all right, 14 and 5 batches of simple and extraordinary respectively must be produced.